Welcome to Brain Vision.
When a balloon lifts off, its buoyancy force, as I'm just going to write B, must be greater than or equal to the weight of the balloon and the air inside. So I'm just going to say Fg. Now, we can look at our diagram here for our balloon, and we can say, okay, we're going to have a buoyancy force up and Fg down for both the air, right, Fg air, and also for the balloon. Fg, I'm just going to do Fgb. So we can essentially sum up our forces, right? And we know that the force of buoyancy is equal to the weight of the air displaced. So in our balloon, the weight of the air displaced would be md for displaced times g. And then for Fg, we have two of them, right? We have Fg for air and Fg for the balloon. So we have m hot air g plus m balloon g. Now the g's will all cancel out, and we're left with displaced mass is equal to the mass of the hot air plus the mass of the balloon. Okay. Now, the displaced mass, well, we have a density of the air inside, right? So essentially, what's the mass of the hot air that would be in there? That's what we're looking to find, and we can find that by multiplying our density of the air by the volume of the balloon, right? So this is going to just be density of the hot air times volume is equal to, we don't have m air, that's kind of what we want. And m balloon is given to us as 200 kilograms. We also have these values for density and volume. Density of hot air is 1.244 kilograms per meters cubed. The volume is 400 meters cubed. That's, of course, equal to the mass of the air plus 200. Solve this for mass of air, and you should find that it's equal to about 298 kilograms. And we can turn this mass into a density of the hot air going down. Remember, our volume is still just going to be equal to 400 meters cubed, because that's, again, all the hot air is just filling this 400 meters cubed balloon. And of course, density is equal to mass over volume. So that's going to be 298 kilograms, 400 meters cubed. And we'll get a density of 0.744 kilogram per meter cubed. Now, there is a law, the Gay-Lussac law, which is that density 1 over density 2 is equal to temperature 2 over temperature 1. We can rearrange this and solve for T2, which is just going to be density 1 T1 over density 2. We can then plug in numbers, right? So T2 is equal to density 1, 1.244 times our initial temperature, which is given as 10 degrees Celsius, but we're going to add 273 to make it Kelvin. And divide that by our new density, which we had found up here as 0.744. And you should find the temperature of the hot air in the balloon to make it lift is equal to 473 Kelvin.